Hello friends, I am Sumit Mehta. So I am starting a new series on NCERT 10th class solutions. तो अब इस सीरीज में मैं NCERT के सारे चैप्टर के सॉल्यूशन अपलोड करूंगा. सो पहला क्वेश्चन हमें एक्सरसाइज हम पहले चैप्टर स्टार्ट कर रहे हैं रियल नंबर्स एंड एक्सरसाइज 1.1 आज हम इस वीडियो में सोल्व करेंगे. So the very first question of this video is use Euclid's division algorithm to find the HCF of these two numbers. So पहले देख लेते हैं कि Euclid division algorithm बोलता क्या है. So Euclid division algorithm क्या है कि for any two positive or for any two integers in the NCERT book you will find out that it is stating for any two positive integers, but it is actually defined for all the integers whether it is being negative, positive. Okay, so for any two positive integers a and b, there exist two integers q and r such that a is equals to bq plus r. So using this is called डिविडेंड. ऐसा एक्सप्रेशन आपने कभी देखा होगा. ये है हमारा डिवाइजर. दिस इज क्यू इज आर कोशेंट एंड दिस इज आर रिमाइंडर. So Euclid division help us to find out the HCF of two numbers till HCF जो होगा ये B होगा और जब तक रिमाइंडर हमारा जीरो नहीं हो जाता. इफ द रिमाइंडर इज जीरो द वैल्यू ऑफ B विल बी आर HCF. अगर रिमाइंडर जीरो नहीं है तो हमें ये प्रोसेस रिपीट करना है टिल द टाइम R becomes जीरो. नाउ लेट्स मूव टू क्वेश्चन part 1. So here the greater number is our dividend. 225 is dividend in this case. 135 is divisor. So for this the question will be how much? It will be dividing by 1. So 135 into 1 is 135. Now the remainder will be 90. So this is our remainder. So this is step number 1. As you can see here the remainder is not 0, so now this will become our new divisor and the divisor here will become new dividend. So 135 is equals to 90. So here it is now acting as A, 90 is acting as B. For every two integers A and B there must exist Q and R positive integers. Okay, so applying Euclid division algorithm, so 135 by 90 question will be 1 and the remainder will be how much? 45. So still here the remainder is not 0, the remainder is 45. So now this remainder will become the new divisor and this 90 will become the new dividend. So this is 45 into 2 plus 0. Now as you can see here the remainder becomes 0. So now our divisor in this case is 45. So 45 will be the HCF between 135 and 225. So we have done Euclid's division algorithm to find out the HCF of these two numbers. So the HCF will be 45. Now let's do part number 2. So in this case the greater number is 3820. So this will be our dividend. Okay, 196 will be our divisor. We need to find quotient plus remainder. So dividing 38220 by 196, it will be dividing on 1. So this is 196, this is 6, remainder will be 1862. So 1862 is on 2. So this is 2, 9 to the 18, So it will be divided by 9. So 9 6 the 54, 5 carry, 9 9 the 81, 5 86. So this is again 8 carry, 9 1 the 9 and 5 14. So our remainder will be 8, 0 from above. So this is 9 and this will be 3980. So on 5 it is dividing fully, 3980. So the remainder is 0. So we can express these as Euclid's division algorithm. So this is 38220 is 196 into 195 plus 0. So as I have stated earlier, जैसे मैंने पहले बोला है कि जब ये रिमाइंडर 0 हो जाएगा, so our डिवीजर जो है वो हमारा HCF डायरेक्टली बन जाएगा. So here 196 is the HCF of these two numbers. Now quickly erase the sum part to write down question number 3. So here is part 3. So the greater number is 867 will act as dividend, 255 will act as divisor, and this we are expressing as Euclid division algorithm. The first part is for every two integers such a and b, where a is 867 here, b is 255, there exist q and r integers such that a is equals to bq plus r. Till the time r is not equals to 0, we need to repeat this process and so on. And when r becomes 0, the divisor will be the HCF. Okay, now let's solve this. So 867 is equals to 255. So the question will be 255 into 3. This is 765. 867 minus 765 is 102. So the remainder is 102. So now 255 will become the new dividend and 102 will become our new divisor. So it will divide it on 2 and 102 into 2 is 204. So the remainder will be 51. Okay. So 102 is new dividend, 51 is new divisor, 51 into 2 is 102 and the remainder will be now 0. So once the remainder is 0, the divisor will become the HCF of the two numbers. So the HCF of these two is, इनका HCF कितना हो जाएगा अभी 51. So I hope students you become pretty clear that how to solve HCF using division algorithm. Okay, now let's move to question number 2. So student, here is question number 2 on our screen, in which we are given that show that any positive odd integer, पहली बात तो यहाँ पे ध्यान देने वाली है odd integer, is of the form 6q plus 1, 6q plus 3 and 6q plus 5, where q is some integer. So as you remember that what Euclid division algorithm is, Euclid division algorithm states that for any two positive integers a and b, where a is greater than b, there exist two integers q and r such that a is equals to bq plus r, where r can take the values greater than equals to 0 and lesser than the divisor itself. So suppose let b is equals to 6, because we need to find out of the form 6q plus 1, 6q plus 3 and 6q plus 5. So I have taken here b as equals to 6. So this becomes a is equals to 6q plus r. So where r can take the values lesser than 6 and greater than equals to 0. So how much values r can take is 0, 1, 2, 3, 4 and 5. So r हमारा कितनी वैल्यूज ले सकता है? ये 6 वैल्यूज ले सकता है. So by putting all the values of r here, a की कौन कौन सी वैल्यू बन जाएंगी? पहले r को हम 0 डाल लेते हैं, 6q, so this becomes 6q plus 1, 6q plus 2, 6q plus 3 plus 4, 6q plus 5. So all these values a can take, but what we need to prove is show that any positive odd integer. So if you see clearly here, so the points or the number that I am circling here is these all are even integers. Why these are even integers? Because I can take 2 out of these common. So from this I can take 2 common and this will become 3q plus 1. If I take 2 out of these common, so this is 3q plus 2. So we need not to take these numbers because these are even integers. So what we are left with is 6q plus 1. हमारे पास क्या क्या बच गए हैं? 6q plus 3 and the last is 6q plus 5. So hence we prove that a is of the form 6q plus 1, 6q plus 3 and 6q plus 5. आई होप स्टूडेंट्स आपको समझ आया होगा. अगर फिर भी आपको कोई डाउट है इस क्वेश्चन में, सो प्लीज कमेंट सेक्शन में कमेंट जरूर करें. नाउ लेट्स सी क्वेश्चन नंबर 3. So students, here is question number 3 on our screen, which says an army contingent of 616 members is to march behind an army band of 32 members. In a parade, the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So अब आपको यहाँ पे क्वेश्चन अच्छे से समझना है. पहले हमारे पास क्या है, दो ग्रुप्स हैं. वन इज आर्मी कंटिंजेंट ऑफ 616 मेंबर्स. सेकेंड इज आर्मी बैंड. अब क्या हो रहा है कि आर्मी बैंड वाले जो हैं ये आगे चलेंगे, मींस दीज पीपल विल लीड. अब क्या बोल रहा है कि ये जो पीपल है लीड करेंगे और आर्मी कंटिंजेंट वाले इनको फॉलो करेंगे. सो व्हाट वी नीड टू फाइंड आउट हियर इज इन द टू ग्रुप्स आर टू मार्च इन द सेम नंबर ऑफ कॉलम्स. व्हाट इज द मैक्सिमम नंबर ऑफ कॉलम इन विच दे कैन मार्च. सो हमें सीधी सीधी बात है कि इन दोनों नंबर्स का HCF निकालने को बोल रहा है. अगर हम इनका HCF निकाल लेंगे सो उतने ही पीपल लीड करेंगे और सारे इनको फॉलो करेंगे पीछे नंबर ऑफ रोज में. तो ये ऐसे ऐसे कॉलम्स बन जाएंगे हमारे. सो व्हाट वी नीड टू फाइंड आउट इज द HCF ऑफ 616 एंड दिस. सो हियर 616 becomes A, 32 becomes B. So this is A is equals to BQ plus R types Euclid division algorithm we are applying here. So applying Euclid division algorithm here, so what we will get, the question is 32 को हम किससे मल्टीप्लाई करें कि हमारा क्वेश्चन जो है, चेक कर लेते हैं भाई फटाफट. 616 upon 32, so this is 1, 32, we will be left with 296. 32 into 8 is 240, 256. So this is 32 into 9. So this is 8 and 1. This is 288. The remainder will be 8. So this is 19 plus 8. So this is our remainder 8. So we need to apply the Euclid division algorithm again till the time r becomes 0. So we will apply it here again. So 32 is our new dividend, 8 is our new divisor. So question will be 4 plus remainder will be 0 in this case. So 8 is the HCF of 616 and 32. So what is the maximum number of columns in which they can march is, columns will be 8 columns. So our answer to this question is 8. I hope students you are pretty clear about this. Now let's quickly move to question number 4. So student, here is question number 4 on our screen, which states that use Euclid's division lemma to show that the square of any positive integer is either of the form 3m plus 1 for some integer. Okay, so what we need to do is we will apply the Euclid division algorithm here. As you know what Euclid division algorithm says, for any two positive integers a and b such that a should be greater than b, there exist two positive integers q and r such that a is equals to bq plus r, where r can take the values maximum value as lesser than b and greater than equals to 0. Don't forget to write this in your exam, okay? Otherwise the teacher will deduct your marks, okay? So as we can see here, so let b is equals to 2. This is same as of the question number 2, okay? I have assumed let b is equals to 3. Sorry, we need to take b here as 3. So this is a is equals to 3q plus r. So where r can take the values lesser than 3 but greater than equals to 0, putting the value of b here. So r क्या क्या values ले सकता है? 0, 1 and 2. So फिर if r can take 3 values, a की भी 3 values हो जाएंगी. This is 3q plus 0, this is 3q, this is 3q plus 1 or 3q plus 2. So to show that the square of any positive integer is either of the form this or this for some positive integers. So देखो अब ये क्या बात बोल रहा है कि स्क्वायर ऑफ किसी भी पॉजिटिव इंटीजर का या तो इस फॉर्म का होगा या हमारे पास इस फॉर्म का होगा. तो अब देखो a हमारे पास इन तीन फॉर्म्स का आ गया है. अगर मैं इनका a स्क्वायर चेक करूंगा, सो a स्क्वायर कौन कौन सी फॉर्म का हो सकता है मैक्सिमम. लेट्स से टेक एग्जांपल, अगर ये मैं 3 लेता हूँ, ये अगर 4 लेता है एंड ये 5 लेते हैं, तो 3 स्क्वायर इज 9. दिस इज ऑफ द फॉर्म 3q और वी कैन राइट हियर 3m. 4 स्क्वायर इज 16, so this is 3m plus 1 form. 5 square is again 25, this is comes under again 3m plus 1 form. So a का जो स्क्वायर है बच्चों, ये इन्हीं दो फॉर्म्स का आएगा, इसके अलावा किसी भी फॉर्म का नहीं आएगा. सो इफ वी टेक द इंटीजर एज 3q plus 1 and 3q plus 2, तो उसका जो स्क्वायर हो जाएगा इस पॉजिटिव इंटीजर का, दैट विल बी ऑफ द फॉर्म 3m और 3m plus 1. और 3m और ये 3m plus 1 कैसे आया, मैंने एक एग्जांपल लेके आपको बताया है. अगर मैं 3 का स्क्वायर लेता हूँ तो 3 का स्क्वायर कितना हो जाता है? This is 9. So I can write this as 3 times m, some where m will be equals to 3. So 4 square is 16. This is 15 plus 1. So I can write this as 3 into 5 plus 1. So this is again 3m plus 1 form. 5 square is 25. So this is 24 plus 1, which is 3 into 8 plus 1, and this is again of the form 3m plus 1. So the square of any positive integer will always be of the form either 3m or it will be of the form 3m plus 1. I hope students now this will be now clear to you. Okay, let's move to question number 5. So student, here is question number 5 on our screen. It states that use Euclid's division lemma to show that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. तो हम पहले यूक्लिड डिवीजन लेमा तो अब हमें पता ही है, मैं सिंपली ये लिख रहा हूँ a is equals to bq plus r. So now let b is equals to 3. Why I am taking b, that you will later on get to understand, because if I will take the cube of, so this number 9m plus 1 और 9m plus 8 की फॉर्म का इसका क्यूब आएगा. सो दिस इज 3q plus r. अब r मेरा जो है यहाँ पे क्या क्या वैल्यूज ले सकता है? r कैन टेक वैल्यूज 0, 1 and 2 because we know r should lie between greater than equals to 0 and lesser than equals to 3. So r can take these three values. So a can be of the form 3q plus 1 and 3q plus 2. अब अगर a इन तीन फॉर्म्स का है, we need to check the cube of a. So केस बना लेते हैं हम यहाँ पे. केस नंबर 1 में क्या लेंगे हम? a का when a is equals to 3q. So इसका क्यूब ले लेते हैं. So a cube is 27 cube. Okay, so as q is also an integer, So I can write this as another integer. So a cube will be of the form 9 into 3m. So 3m is again an integer. Okay, or you can write 3 cube here. So this is, now you can write this is 9m form. So from first case we have proved that a cube is of the form 9m. So ये वाला part हमारा proof हो गया है. Now let's take case number 2. केस नंबर 2 लेते हैं. केस नंबर 2 में क्या है? a is of the form 3q plus 1. अब इसका क्यूब करते हैं तो a cube is 3q plus 1 whole cube. So this is, we know the formula of a plus b whole cube is a cube. So 3q whole cube plus 1 cube plus 3 into 3 cube, and this is a plus b. So this is 27 cube plus 1 plus this is 27 q square plus 9 cube. So taken 9 common from all these, this is 3q cube plus 3q square plus q plus 1 except. So as we know that q is an integer, so all these will result into an integer. Now this I can write as of the form 9m plus 1. ये जो सारी चीजें हैं ये एक इंटीजर ही तो होंगी, तो उस इंटीजर को हमने एक m की फॉर्म में लिख लिया है, because m is also an integer. So a cube जो हो गया है हमारा 9m plus 1 फॉर्म का हो गया है. Okay, now let's quickly make some space for case number 3. So case 3 क्या है? When a is of the form 3q plus 2. Take the cube of this positive integer a. This is 3q plus 2 whole cube. So applying the formula of a plus b whole cube. So this is 3q cube plus 2 cube plus 3 into 3q into 2 into 3q plus 2. So this is 27 q cube plus 8 plus this is 9 into 2 18 into this is 54 q square plus 9 for the 36 cube. Okay, so taking 9 from all these common, this is 9, but we will be left with 3q cube plus 6q square plus 4q plus 8. This 8 is written over here. So as we know that q is an integer, so all these will give an integral value, and we can write this as a new integer m. Okay, so this is of the form 9m plus 8. So we have covered all the cases. In case 1 we have proved that cube of any positive integer is of the form 9m. In case number 2 we have proved that cube of any positive integer can also be of the form 9m plus 1, and in the case 3 we have also proved that cube of any positive integer may also be of the form 9m plus 8. So with this our exercise 1.1 is solved. And student, if you have faced any difficulty or still any question is not clear to you, please comment in the comment section में जरूर कमेंट करें. और अगर आपको ये वीडियो पसंद आया है तो इसको लाइक, सब्सक्राइब और शेयर जरूर करें. थैंक यू स्टूडेंट्स. हैप्पी लर्निंग.